There is three objectives for this method. The first one to define the introduction and forward-backward method. For the second one to determine how to prove using forward-backward method. And the last one to show how to apply forward-backward method. For introduction of direct proving method, a statement is considered as a sentence or proposition that has value whether it is true or not. A proof demonstrates the validity of a statement by an argument that is expressed in mathematical language. Every statement will have a hypothesis and conclusion. Hypothesis is something will be assumed true, while conclusion is something to be proved.
So now I am going to explain the definition of forward-backward method. So backward method is a process of reaching the value of the conclusion is true, which is statement B. And forward method is hypothesis, which is statement A will be considered true. It will be derived to be another statement. For example, A1. The last statement derived from forward method should be linked up with the last statement obtained from the backward method. So now I am going to talk about how to prove using forward-backward method. So for the first step is we should recognize and differentiate statement to determine hypothesis as statement A and conclusion as statement B. And the statements given can be determined as A implies B. So next step is we can assume that hypothesis, which is statement A, is true. And the final answer should have an analysis and condensed proof. So, for the step 3, we can derive another situation or definition that are manipulated from the hypothesis and conclusion to ease the proving process. And the last step is analysis proof are made to make the proving process is clearer and to show how the another situation suits the conclusion. And lastly, condensed proof is made to explain the proof of the calculation and the proving method. So now we are applying these steps in our examples. So let's see.
Okay, in this part, we will show you guys examples of questions that use the forward-backward method so that you guys can be more understand about this topic. Example 1. The question is, if m is odd and n is odd, then m times n is odd. Prove using the forward-backward method that for all integers m and n, write analysis of proof and the condensed proof. Okay, before we answer the question, first we must identify the statement. Second, use a backward process. And the last step is use forward process until the backward and forward equivalent. Okay, for the solution, analysis of proof, if m is odd and n is odd, then m times n is odd. We turn this statement to if A then B form. Then we get statement A is m is odd and n is odd for our hypothesis. Then got statement B that m times n is odd for our conclusion. Okay, for the second step, use backwards process. Statement B1, m times n equal to 2k plus 1 for some integer k. This is according to definition of odd integer. Okay, next step is use forward process until the backward and forward equivalent. Since the hypothesis states that m and n is odd, so for the statement A1, by using the definition of odd integer, we get statement A1 is m equal to 2a plus 1 for some integer a. And then statement A2 is n equal to 2b plus 1 for some integer b. This is also by according to definition of odd integer. And now, statement A3, we need to substitute m equal to 2a plus 1 and n equal to 2b plus 1 into the equation m times n. So, statement A3 is m times n equal to 2a plus 1 times 2b plus 1. And we get 4ab plus 2a plus 2b plus 1. And then we factor out 2 and we have 2ab plus a plus b plus 1. Next, for statement A4, we simplify that statement A3. We get m times n equal to 2k plus 1, where k equal to 2ab plus a plus b. So, now we can see that statement A4 and statement B1 is equivalent. So, this is how we solve this kind of question by using forward-backward method. For condensed proof, from hypothesis, m is odd and n is odd, then m equal to 2a plus 1, n equal to 2b plus 1. Since m times n equal to 2a plus 1 times 2b plus 1 equal to 2ab plus a plus b plus 1 equal to 2k plus 1 for some integer k equal to 2ab plus a plus b. Therefore, m times n is odd integer.
For example 2, the question is, if p and q are even integers, then 3p squared plus pq is divisible by 4. For the solution, A, p and q are even integers, that was the hypothesis. B, 3p squared plus pq is divisible by 4 as the conclusion. And for the B1, 4 divide with 3p squared plus pq, 3p squared plus pq equals to 4k for some integer k. That is the definition of divisibility. So for the forward process, A1, p equals to 2m, q equals to 2n for some integer m and n as the definition of even integer. So for the A2, 3p squared plus pq equals to 3 times 2m squared plus 2m times 2n equals to 12m squared plus 4mn equals to 4 times with 3m squared plus mn equals to 4k, where k equals to 3m squared plus mn. This we can conclude that A2 is equivalent with B1. For the condensed proof, given that p and q are even integers, then p equals to 2m and q equals to 2n for some integer m and n. Since 3p squared plus pq is divisible by 4, then 3p squared plus pq equals to 4k for some integer k. Therefore, 3p squared plus pq equals to 2 times 2m squared plus 2m times 2n, then there exists integer k such that 3p squared plus pq equals to 4k, where k equals to 3m squared plus mn.
Right now, I'm going to show you example 3. Let's move.
Example 3. If right triangle RST is an isosceles triangle, then square root 2 plus 2 times a congruent side is the perimeter of the triangle RST. Analysis proof. We know that if A then B, equivalence to A implies B. So A is right triangle RST is an isosceles triangle, which is the hypothesis, and B is square root 2 plus 2 times a congruent side is the perimeter of the triangle RST, is the conclusion. Next is backward process. B1 is square root 2 plus 2a, where a is equal to RS and equal to ST. B2 square root 2 plus 2 ST. Forward process. A1, RS is equal to ST, definition of isosceles triangle. A2, perimeter equal to RS plus ST plus TR. Perimeter is equal to 1 base plus 2 sides. A3, TR square equal to RS square plus ST square. A4, TR equal to square root RS square plus ST square, which is A3 and A4 is Pythagorean theorem. A5, perimeter equal to ST plus ST plus square root ST square plus ST square is equal to 2ST plus square root 2ST square equal to 2ST plus square root 2ST equal to square root 2 plus 2 times ST. This A5 process is when we substitute A1 and A4 in A2 and then simplify until reach B2. From this forward-backward method, we know that A5 is equivalent to B2. Condensed proof. From hypothesis, RS equal to ST. By using Pythagorean theorem, we know that TR square is equal to RS square plus ST square. Obtain TR equal to square root RS square plus ST square. And by the formula of perimeter, we know that RS plus ST plus TR is equal to ST plus ST plus square root ST square plus ST square and equal to 2ST plus square root 2ST square equal to 2ST plus square root 2 times ST. And the end of this proof, we know that we obtain one perimeter, which is RST equal to square root 2 plus 2 times ST.
That's all for example 3. Now, let's move to the conclusion part.
By the end of our group project, we know that the other method rely on the forward-backward method. And by using this method, we know how to prove a statement, and in this method, the forward process is the most helpful process.
I think that's all from us. We hope that you guys enjoyed the video and help you to be more understand about forward-backward method. Thank you and see you again. Bye bye.